Hi, welcome back. So we've got a few sessions under our belt. Let's talk about what MATLAB is. MATLAB stands for Matrix Laboratory. So all we've done is assigned the value 3 and 4, I think, to x and y. We made a couple dynamic variables. Why don't we look at how to make a matrix? So like I said, we've assigned the value 3. Let's just assign the value 5. We always assign 3. And we see over here that sure enough there's this x and it has the value 5. But what see how this icon looks like a 4-panel window frame? That icon means that it's a matrix. So if we take the size function, which basically is going to return our matrix dimensions of x, it says that we're 1 row by 1 column. And if we open the variable x, we can see it just has this number 5 here, just like we'd expect. But what this does a great job of illustrating is that it could be 10,000 by 10,000. It doesn't have to be 1 by 1. So let's talk about how to make a variable that's a little larger than just a single value. So we do that by using square brackets and then putting in a couple of values. I'm going to put in 3 and 4. So you can separate them with a comma or separate them with a space. I like to use commas because it's a little easier to read. So if I press enter here, now the first column has a 3, the second column has a 4, and you can see x is 3 and 4 there. In like manner, we can assign multiple rows. So you might ask, well, how do you separate the rows and the columns? All you have to do is separate column elements by the comma, and then you use a semicolon, which is kind of like a carriage return, to get to the next line. So 3, 4, and then maybe we'll say 5, 6, and end the square bracket. And now we have 3 and 4 in the first row, 5 and 6 in the second row. So that's great. What if we have a matrix like this? Let's make it slightly more complicated. What if we have a matrix? I'm going to clear the command prompt. What if we have a matrix that looks like 1, 2, 3? That's the first line. And then 4, 5, 6. That's the second line. And then 7, 8, 9. Okay, now we have a 3 by 3 matrix. We use the size function to check our dimensions again. We can see this. 3 rows, 3 columns. Well, what if we just want the 5 out of that? Well, we can use array indexing or matrix indexing and just pull that out. So I want, of x, I want the second row, the second column, and I can get the answer 5. This is really powerful because we can pull out individual things or throw the whole matrix around and use it in other definitions. So I could make another variable named y and say that y is 2 times x, and now y is 2, 4, 6, 8, 10, 12, 14, 16, 18, just like you'd expect. Scalar multiplication there, so, or the dot product. So yeah, I think that's enough for today, but I want to get you used to the fact that every variable, even though we can assign it a single scalar value, every variable can be a full matrix of nearly arbitrary dimensions. So this one, x we have here is 3 by 3. We could open y and see y is 2, 4, 6, like we saw before. So these are almost look like Excel spreadsheets, right? They have to be numbers, they have to be square, or not square, but they have to all have numbers in them. But it's almost like throwing Excel spreadsheets around. If you're curious about what a matrix is, I encourage you to go over to Wikipedia and read about matrix, mathematical matrix, and linear algebra, and you'll see there's a tremendous amount of things, it seems like, especially in engineering and physics, where it just basically makes your life easy. It's kind of an accounting thing. Anyway, that's all for today. Thanks for watching.